and they were conducting exercises, and the theory was they launched an SM-2 missile, which is a big anti-aircraft missile. It's about 18 feet long. And instead of the drone, this is the theory, do not quote me on this as being real. The theory said the drone that was the target was behind the 747, so what did the missile track on? The 47 instead of the drone hit the airplane, except SM-2s don't actually hit. The warhead on an SM-2 is like a giant shotgun shell, cone-shaped. What it does is it's got a proximity fuse on it. When it's within 100 feet of the target, it blows that cone of pellets, just like a shotgun shell, into the side. It's very deadly. It's good for shooting down airplanes. Except, oh yeah, same idea. But you don't see any of that inward crushing that you see with that sort of thing.
Wouldn't they also find bits of missile in the ocean?
Theoretically.
Small,
Small. Yeah, that's why it's a theory. And actually, disproven theory. I've served on ships. I guarantee you, no way you're going to keep everybody quiet if that's what really happened. A few years earlier, we did actually shoot down an airliner over in the Persian Gulf, USS Vincennes. The Iranians really loved to play with us, and they played with us one too many times. They had an Airbus A300, which was a commercial airline flight, but it's got a transponder on it that makes it look like an F-14. Now, you guys all seen Top Gun?
Yes.
How did the Iranians end up with F-14s?
Dead.
We sold them to them back when the Shah was in power, and they changed regimes. Now, the Vincennes doesn't really have any choice. This thing looks like an F-14. It's not acknowledging the radio calls, and it gets close enough to them. What did the captain have to make the decision to do? He shoots them down. Now, we look like the bad guys, but we fessed up. We knew we did it. We didn't try to hide it. Why wouldn't we have done that here? Because we didn't do it that way. This is an accident. Ultimately, probably caused by a shortened fuel pump inside that center fuel tank. You see how ballistic trajectory analysis helps us put it back in flight. Nothing's flying in formation. Now, the big one. February 1, 2003. Shuttle Columbia, re-entering at an altitude of 217,000 feet at an airspeed of Mach 12.5, which is slower up there, but catastrophic enough when your left wing melts off and you turn sideways into the airstream. This is the ground plot of debris. Dallas-Fort Worth, Houston, Louisiana border.
What was the length of that? Give us
170, the core debris field is 170 miles long.
Whoa.
There are parts identified all the way as far west as Weatherford, Texas. That's the furthest west they were identified. Now, how do we produce a ground map like that? Yes, you do. You get 10,000 volunteers from fire departments, police agencies, military agencies, and you do a line walk. And you identify 60% of that orbiter. They even found parts of the crew. They found an event recorder.
Parts of the crew? Like,
This took about 4 months.
parts?
Now, the other thing is, Matt, you've probably been over in East Texas. Any of you folks been in East Texas?
Yes.
When you get away from the cities, what are those woods like? They're full of these scrub, thorny bushes. Some fool imported the things back about 200 years ago, thought they were good. They got purple barbs on them about yay long that have a sap on them. It's very poisonous. Imagine having to do this, but they did it. It took them 4 months and 10,000 people to reconstruct just the ground plot. And then it took almost $20 million for the computer time to process this and put it back in flight.
And what plane was this?
This is Columbia. space shuttle, the second space shuttle last.
How many people got hurt during this procedure?
Say again?
How many people got hurt during the procedure?
Quite a few actually. NASA didn't, I don't think NASA ever reported the numbers. I know a couple of them from here, from Prescott Fire that went. Yeah, they got scratched. A couple of them ran into those big purple African thorns. Not fun. Just to reproduce this, we know an awful lot in real time about the atmosphere, down in the troposphere. But when I get up in the outer edges of the stratosphere, we don't have real good real-time knowledge of what the winds are doing. Now the air's a lot thinner, but do they still have an effect on how this debris falls? Sure does. And what they had to actually do is a whole bunch of research trying to figure out what those upper air currents really look like to be able to produce this $20 million grid bank. Now it did help understanding the breakup sequence. With Columbia, you had one giant piece of help. Well, there were no flight recorders on the vehicle, but where was everything being recorded? Ground control in Houston. And up, the first indication of a fault that they had was some of the sensors associated with the left main landing gear of the orbiter just stopped sending data. Now, most of you have probably heard of this accident. When did the accident sequence start? On launch. Because very clearly, in hindsight, remember what hindsight is, it's 2020, we can see very clearly. Reviewing the videos of the launch, you can see as the vehicle is ascending, a big old chunk of foam come off that external fuel tank and come down and whack that left wing. At a delta V, who knows what delta V is? V1 minus V2, for the rest of you. Of a delta V of almost 500 miles an hour. Now, chunk of foam, about the consistency of a styrofoam cooler, about the size of a briefcase.
Oh.
NASA didn't think anything of it. They actually saw it and didn't think anything of it.
What was it?
It was a chunk of the insulation off of the external fuel tank. External fuel tank, what's it full of? Liquid hydrogen, liquid oxygen. Now what happens then? That thing whacked a hole in the leading edge of the orbiter. You've got the heat protection tiles on the outside. But once you get past them, what is the airframe? What were the airframes of all the shuttles made out of? Aluminum. Aluminum melts between 9 and 1200 degrees Fahrenheit. When that foam whacked into that wing and opened up a 2-foot hole in it, didn't matter when they went into orbit. That's not a pressurized area. NASA never did decide to retest anything and take a look at it. And those people were coming back. And as they're re-entering, what are they picking up? What's happening to the belly of that thing?
It's going on.
It's heating up. Frictionally induced heating, you literally are creating plasma. Not the kind that goes in your blood, but the kind where the atoms are fusing. At about 2,800 to 3,000 degrees Fahrenheit. And as soon as that found that 2-foot hole in the thermal protection, what'd it do? It started melting stuff. And ground control actually recorded it in hindsight. And as those sensors are dropping offline, the last transmission from the vehicle is interrupted mid-sentence. Because what happened right then?
It melted
The wing off.
Another wing, yeah.
Yeah, the whole wing came off. They turned sideways at Mach 12.5. Some of you may remember the video. There's a guy in, I think he was in Arlington, Texas, videoing it. Instead of one big bright glowing ball, he's got 5 of them, all trailing smoke. NASA knew right then they lost it. Reconstructing this helps them solve the problem. Now, one of the fixes is simply to put cameras. How many of you saw the last few space shuttle launches? I saw the first 5. I didn't get to see any later on. I did see the first 5, but they were all this bird. It's impressive. One of the fixes that they did was simply to put cameras on the external tank so that you can actually see the belly of the vehicle and the thermal protection. And every launch after this, what do we see? Pieces of that stupid insulation, knocking tiles off, doing other things. We didn't have any more hit the wing, because they did some reinforcement to the area of that external tank. Now, there was a lot of discussion about, do I have a repair capability in space? Could they have ever fixed that hole? Well, I don't know. We solved Apollo 13. And that shouldn't have come out right. We should have lost that. At least they would have had a chance if they knew about it. I got on the soapbox there, didn't mean to. But this one, this is ultimately human error. It involves mechanical failures. This is human error. And actually, this is management. Every accident you ever look at, management's involved somewhere. Whether they're involved a lot, involved a little, management is involved in causing that accident. Here, it's glaring. Probably had something to do with the decision finally to shut the program down. Yeah.
Wasn't there a crash when the rocket went straight up and then just came back down?
Oh, a lot of them early on.
No, but it was like a really big one
Challenger.
in the 80s.
Challenger, totally different thing. Ballistic trajectory analysis would have helped Challenger. Challenger, management accident, was a decision to launch at a temperature much colder than they ever tried to launch. Now, one of the things in human factors we look at sometimes is why people make decisions. What was different about that flight of Challenger than the previous 24 shuttle missions? What was different? Anybody remember?
Temperature.
The teacher. You got a teacher, you got a civilian on this vehicle. You've got millions of school kids watching this thing on TV. And NASA didn't want to disappoint them. And they've got engineers from the people that built the solid rocket boosters trying to tell them, we can't certify that the joints on that external tank, that the O-rings will seal properly at those temperatures. They get brittle. And sure enough, they were right. You look at the launch pictures from that thing, you can very clearly see it exploded at 73 seconds after launch. You can very clearly see a bright jet coming from that right solid rocket booster. And what it actually hit was the steel strut that attaches the SRB to the external tank. When it melted it in half, aerodynamically the whole solid rocket booster started swinging out, and then aerodynamically slammed back in, and about that much of that strut went right into the hydrogen tank in the external tank. When you release the hydrogen, what happens? Boom. That's what happened there. Different circumstance.
Yeah.
We have lost 2 shuttles. We lost 2 shuttles. We know very precisely in hindsight what the failure rate is. It's 1 for every 61 flights.
Oh.
That is a very risky endeavor in hindsight. That's hindsight. Now, as accident investigators, what's the most important tool you take out of the scene with you?
Your eyes.
Well, more than that, what's behind your eyes?
Oh, your brain.
Brain. You gotta keep an open mind. Be willing to look at what you're trying to look at. Be willing to be objective. Try not to jump to conclusions too fast. We all do it, it's human nature. But you've got to try to keep an open mind and look at what the evidence tells you. Now, next week you're going to be looking at physical wreckage. You're going to have a set of information to start the exercise, and you've got to figure out how that happened. That's what you got to do. Now, if I can figure out why it happened, maybe I can stop the next one. That's why we investigate accidents. That's what's so frustrating about this Malaysian situation. One, it's not an accident, almost certainly. What happens when we can't find it? We don't know. We can't fix something we don't have evidence for. There is no probable cause until we find it. And if we don't find it, or, now here's the other scenario. Denny, would you turn the camera off? I do not want to hear this on the 6 o'clock.